Hello students, welcome to the today's lesson today. So today we are going to discuss definition of irrational numbers, theorem 1.2 and proof of root 2 is irrational. So let's go to theorem 1.2 statement. Let P be a prime number if P divides A square, then P divides A where A is a positive integer. Remember students, here P must be a prime number. You can't take any composite number. P can be only 2, 3, 5, 7, 11, 13 like these prime numbers. And A can be any number greater than 1 positive integer. So let's see the proof of this. Let P A be a composite number which can be represented as product of prime numbers P1, P2, P3, so on Pn, where P1, P2, P3 are all prime numbers. Not necessarily distinct, but their composition can change, order can change, but composition will be remain same. So let's square on both sides. A square is equal to P1, P2, P3, so on Pn into P1, P2, P3, so on Pn. Since we have squared on both sides, on the right hand side also becomes P1 square, P2 square, P3 square, so on Pn square, all multiplication. Now as per the theorem we are given P divides A square. So see, by fundamental theorem of arithmetic what it says, P must be 1 of A square. Since P divides A square, in the prime factors P must be 1 of the prime factors of A square, which are P1, P2, P3, so on. So when you consider P must be 1 of P1, P2, P3, so on Pn square, then A is equal to P1, P2, P3, so on Pn, then it directly follows that P divides A. So it's simple, right? Simple, straightforward. A square is divided by P. Since A is equal to P1, P2, P3, so on, then P must be among P1, P2, P3, so on Pn. So remember this, children, this theorem is very important. It is especially used in almost all of the irrational number proofs. Let's go to the next question. So rigorous proof of root 2 is irrational. So in this session we'll prove root 2 is an irrational number. That means it cannot be kept in the form of P by Q, where P and Q are co-prime. So for the proof, children, let's assume root 2 as rational number. So by assuming root 2 as rational number, we'll solve. If we get a convincing end, then root 2 is an rational number. If we get to a mathematical confusion or the impossibility, then root 2 is not rational, root 2 is irrational. So let's start. Let's assume root 2 is a rational number, then root 2 must be in the form of R by S, where R and S can be any positive integers. So if R and S have a common factor other than N, then it can be written as A by B. Then the equation becomes root 2 is equal to A by B, where A and B are co-prime. If A and B are co-prime, students, what we know? We know that A and HCF of A and B is equal to 1, right? And B is not equal to 0. So next step, square on both the sides. Root 2 square is equal to A by B whole square. We bring B into the left hand side, which the equation then becomes 2B square is equal to A square. Since we assumed A and B as co-primes, and on the other side of the equation 2 is there, 2 must divide A square by theorem 1.2. In the previous discussion we discussed, right? If 2 must divide A square. So let A be 2C, where 2 and C are co-prime. A can be represented as 2 into C. Let's substitute A is equal to 2C in the equation. We get to the step 3, where 2B square is equal to 4C square. Cancel 2 on both sides. B square is equal to 2C square. Again, applied theorem 1.2. So b square is equal to 2c square. Since these are all integer numbers, then b square should have 2 as one of the prime factor. But what we assume, a and b are co-prime. What we are getting in is the outcome 2 has b, a has b as prime factor, and b also having prime factor as 2. So our assumption is wrong. What is the conclusion? Since our assumption that root 2 is rational number, which is wrong, that indicates root 2 is an irrational number. So remember this, children, this proof is important. You can remember in 4 simple steps. First step, assume root 2 the given number as rational number and keep it in the form a by b. Then square on both the sides. Then substitute the number which we are getting on the which is supposed to be rational or irrational as the a should be a prime factor of 2 and c, some other constant c. Then the final steps, we prove that the co-prime condition is not satisfied, so we prove that our assumption is wrong, and eventually the number becomes irrational number. So today's homework, student, prove that root 2 is irrational. Do this by yourself, and if you have doubts, comment.